today's video is going to be a particular type of redox reaction called a disproportionation reaction. Now, what makes a disproportionation reaction unique is the fact that only a single reactant is going to be used in both half reactions. So, a simple example of a disproportionation would be right here. There would be a situation such as this redox reaction here, which we'll do in base, where I have one molecule of Cl2 disproportionating to give me chlorate ion and chloride ion. Alright? Now, I left some spectator ions in here because I want to give us a little more practice with regard to dealing with how to get from a molecular equation to a net ionic equation. We know how to do it from the standpoint of an acid-base reaction. We know how to do it from the standpoint of a precipitation reaction. It's exactly the same thing here. Anything that we have in solution as a salt that we can dissociate, we do dissociate. We then look for spectators and we get rid of them. So let's do that in this particular case. So here, I've got chlorine gas. Now that's molecular, so I can't pull it apart. I'm going to leave it as chlorine gas. And now what I'm going to do is I'm going to break these two things, which are salts, apart. So I have potassium ion here, I have chlorate ion here, I have potassium ion here, and chloride ion there. Okay, so once we assign the charges, we see how we can break these things apart. So I'm going to get a potassium ion in solution, I'm going to get a chlorate ion in solution. Keep those charges in there. Another potassium ion in solution, and a chloride ion in solution. Alright, so all of those are in aqueous solution. So now what we do is we look at this thing and recognize there's no potassium ion on the left, so that tells me it has to be a spectator. It's not part of the redox reaction, balanced or unbalanced. So we get rid of the spectator ions, and now we're just going to write the net ionic unbalanced equation here. Okay, so Cl2 gas, that's going to be going to chlorate, ClO3 1- in aqueous solution, plus chloride, also in aqueous solution. So now that we look at this, we can now identify what our half reactions need to look like. So one half reaction has to be the chlorine gas going to the chlorate. The other half reaction by default has to be the chlorine gas going to the chloride. So this is indeed an example of a disproportionation reaction. We have one single reactant being used in both half reactions. So we can see that in this particular case quite clearly now. So next thing we got to do is write out our two half reactions independently so we can balance them. Alright, so I've got a Cl2 here. And in our first half reaction, that's going to go to a chlorate ion. And in my other half reaction, it looks like the chlorine gas going to the chloride. Alright, so now we can balance these two half reactions as we already know how to do. So let's see the first one. I'm going to balance the chlorines first. To do that, I need to have a coefficient 2 in front of the ClO3 1-. Chlorines are balanced now. Looks like I now have to get 6 waters on the left. 2 times 3, that's my 6 waters. And now I've introduced 6 hydrogens here, so I've got to put twice 6, which is 12 hydrogen ions on the right. Okay, so now we're going to balance our charges out. So let's see, I've got 0 charge here. Both of these species are molecular, so they carry no charge. And over here, it looks like I've got 2 times a 1-, that's 2-, 12+, that looks like a net charge of 10+ on the right. So in order to get from 10+ to 0, I need to add 10 electrons to the right-hand side of this half reaction. All right, let's do this next half reaction. All right, my chlorines need to be balanced, so I'm going to put a 2 out front there on the right. And it looks like here I've got no oxygens to worry about, I've got no hydrogens to worry about. So now all I got to do is balance the charge. Okay, I've got 0 charge on the molecular chlorine gas here. I've got 2 units of negative charge on the chloride. So it looks like now I'm going to have to add 2 electrons to the left-hand side here to balance the charge. All right, so now I need to add the 2 half reactions together, but I got to first make sure that the electrons are going to cancel out. Looks like I got 10 electrons on the top half reaction. So it looks like on the bottom half reaction, I need to multiply through by 5. My 2 electrons times my 5 will give me my 10 electrons to balance everything out. Electrons ought to cancel now. So now we're in a position where we can go ahead and add our half reactions together. All right, so starting at the top, I've got Cl2 gas. I got 6 waters. And then I've got 5 Cl2s here. It's also gas. All right, on the other side of the arrow, I've got 2 chlorates. All right, I've got 12 hydrogen ions. And I've got 10 chlorides. All right, so let's make sure we got that right. So now, of course, the one thing we can do is we can add the 2 chlorines together to give us 6 chlorines. So what I think I'm going to do at this point is I'm just going to get rid of this 1 chlorine here and combine that over to the other chlorine and make that a total of 6 chlorines. All right, so now we should be well set up. Now this would be a balanced reaction in acid, but we said we wanted to do this one in base. So let's do that final correction that we need to do to get to base. All right, so it looks like here I've got a total of 12 hydrogen ions. So to balance this, it looks like I'm going to have to add 12 hydroxides to that. All right, those 2 will combine to give me 12 waters. All right, and if I do it to one side, we have to do it to the other side. So I'm going to go ahead and add to this my 12 hydroxides. We've got room up here, so let's just stick them up here. Okay, there they are. And let's see if we can now simplify this thing anymore. I see 6 waters here. I can cancel these 6 waters out with 6 of the waters here. So that leaves me with 6 waters now on the right. So let's go ahead and pretty it all up. Looks like I've got 12 hydroxides here, plus 6 chlorine gases. All right, and that's going to take me over to 2 chlorates. And I'm going to have 6 waters. And then finally, my 10 chlorides in aqueous solution. And we should now have a balanced redox reaction. So again, a disproportionation reaction works exactly the same way as any other redox reaction. The one thing we note here, since we're working from the standpoint of just one reactant, is we can say that the chlorine gas is both oxidized and reduced. That also means it's both the oxidizing agent and the reducing agent. All right, so we'll practice with this a little bit more next time in class. We'll also do a few more redox reactions involving spectator ions. So we'll see you then.